Okay, this is going to be part 6 of the series on trigonometric substitution. And if you haven't done it, I would definitely watch the previous videos and they'll kind of show you how we've gotten to this step. Now we're going to use the same series of 8 steps that we used on the previous ones. The problem looks a little different. Each one has a little different variation in it. So you've got the square root of x squared minus 16 divided by 2x, and you want to find that antiderivative. Now again, let's take a quick look at the steps. Just to remind you, we'll go through the same ones that we've used before. And those steps look like this. So the first one says this: determine which of the 3 forms that you have. Now just a reminder, what the 3 forms look like would be this. You've either got the square root of a squared minus u squared or x squared. You could have the square root of a squared plus an x squared, or you could have the square root of an x squared minus an a squared. And it's got to be one of those 3 cases. So let's take a quick look at our problem. And I would suggest that you go ahead and rewrite these. So what we'll do is, if you write it in the form of something squared plus or minus something squared, it'll make it a little bit more obvious what the choice is. So we'll make this be, and we can do a couple things here. Well, we'll just go ahead and start with just the integral. So we've got the integral of dx, and we'll write it as the square root of, and instead of x squared minus 16, we'll write it as, in parentheses, x squared minus, and we'll change that 16 into a 4 squared. And this will all be divided by 2x. Now, the way we're going to set it up, this is going to be u, and this is going to be a. So we'll have u and a, and it'll look like that. So really what we've got is the square root of u squared minus a squared. So if we look at the 3 cases, what it will look like, it'll actually fall into this 3rd case right here. So again, for this, you can pretty much forget about the first 2 cases and just concentrate on this. And really, the only 2 formulas that you're going to need to solve the problem would be this. So the square root will turn into an a times the tangent of theta, and u would be equal to a times the secant of theta. So with that in mind, let's go back and look at our problem now. So our problem looks like this. And I think we'll go ahead and put those formulas up here again. So what our 2 formulas would look like, again, the square root is a times the tangent, and u is equal to a times the secant. So let's go ahead and start through the rules and take a quick look at them. First of all, we've decided what type problem we have. So the second step says this: now go ahead and change the entire problem from a problem in terms of x into a problem in terms of theta. So you start by changing the square root in terms of theta, then dx in terms of theta, and then any remaining x's in terms of theta. So what we'll do is, this will be step number 2, and again, I think we'll do it in red just to stay consistent here. So this will be step number 2. And what step number 2 says is change the square root. So the square root here is the square root of, now originally it was x squared minus 16. And we're going to change it into a times the tangent of theta. Now again, we rewrote it like this, is the square root of, and we wrote it as x quantity squared, and changed the 16 into a 4 squared. Now remember, the x was equal to u, and 4 is equal to a. So the way this problem is set up, a is equal to 4 times the tangent of theta, and there is how you'll change the square root into, express it in terms of theta. So you've got step number 2 done. And let's take a quick look at step number 3. So now it says express dx in terms of theta. Well, to express dx in terms of theta, you got to first of all start with x. So we'll do this. We'll make this be step number 3. And we'll start with u is equal to a times the secant of theta. So start with the formula. Now the things that you know that u is equal to x, you know that a is equal to 4, and you've got the secant of theta. So it looks like that. Now you don't want x, you want the derivative of x, or the differential of x. So this will be, in this case, the derivative of x with respect to theta would be equal to 4. And then again, the derivative of the secant is the secant tangent. So that'll change into the secant theta, tangent theta. Now you want the differential x, so dx is equal to 4 times the secant of theta times the tangent of theta, and then finally d theta. So now you've got dx in terms of d theta. So you got the second step, or third step done. So now what the fourth step says, let's take a look at it. Fourth step says, express any remaining x's in terms of theta. Well, in this problem, you've got one remaining x right here, so this will be step number 4. So to express that remaining x in terms of theta, you can really just go to this statement right here. So you know that x is equal to 4 times the secant of theta, and now you've got that last thing. So you've got all the steps taken care of. Okay, next thing says, go ahead and rewrite the integral now in terms of theta. So what we're going to do is just change it from an integral in terms of x into an integral in terms of theta. So what that would look like would be this. This would be step number 5. So what you've got is the integral of, and we'll go ahead and put the bar across right here. Now in the numerator, the square root turned into 4 times the tangent of theta. So you can replace this with 4 times the tangent of theta. Now in the denominator, you've got the constant 2, and it was x, but x is equal to 4 times the secant of theta. So we'll replace that with 4 times the secant of theta. And then finally, in place of dx, replace it with what it's equal to, which would be 4 times the secant of theta, tangent of theta, d theta. So just change each of the 3 parts into what they're equal to. And now go ahead and cancel out what you can. So sometimes you can simplify things just a little bit. So what we'll have, first of all, let's take care of these. You've got a 4 in the denominator and a 4 in the numerator. Those will cancel out. You've got a secant in the denominator and a secant in the numerator. Those will cancel out. 2 goes into 4 and leaves you with a 2 in the numerator. So after canceling everything out, it'll turn into this. This will become, you've got the constant 2 in the numerator. You can bring that outside the integral sign. And you've got the integral, and really all you got here is tangent times tangent is tangent squared of theta. So this will turn into the tangent squared of theta d theta. Okay, so you've got it simplified as much as you can. So let's take a look at the next step. The next step says now evaluate the new trig integral. So you have to find the antiderivative of the tangent squared. But the problem is that you don't have an integral for the tangent squared, so you've got to change it into something that you do have one for. Now just a reminder that the tangent squared, this is one of your trig identities, the tangent squared is equal to the secant squared minus 1. So the trick in this is if you change the tangent squared into the secant squared minus 1, then you do have an integral for the secant squared, and you've also will be able to find the integral of 1. So we'll take advantage of that. So let's get things down here just a little bit. We'll change this into, this will become 2 times the integral of, and we'll make this be the secant squared of theta minus 1 d theta. Now to find the antiderivative of this, you really have to split it up into 2 parts. So we'll go ahead and change that into 2, and we'll split it up into 2 separate integrals. We'll make it be the integral of the secant squared minus the integral of 1 d theta. So again, split it from a single integral into 2 separate integrals. Now the reason you want to do that is that you have a formula for the integral of the secant squared. So you may have to look back and review your integral formulas, but just a reminder, if the derivative of the tangent is the secant squared, then the integral of the secant squared will take you back to the tangent again. So this will turn back into the tangent of theta. You can put a plus c, or we'll save it for a little bit later on. And then also, the integral of 1 d theta just turns into a theta. So this will turn into minus theta, and then we'll tack on a plus c to account for a constant. So that's going to be the answer, but that's the answer in terms of theta. Now remember, you want the answer in terms of x, so let's take another look at our steps again. So the last two steps are this. Draw the triangle and label the sides, and then use that triangle to turn the final answer from theta back into x again. So just like we've done in the previous videos, we'll draw a triangle, label the sides, and go from there. So this is going to be step number, and actually all this was step number 6 right here. So in step number 6, we solve things. So step number 7 says draw the triangle and label the sides. So draw a right triangle. So it's going to have a right angle here. Here's going to be the angle theta. Now I'd suggest you take the time to label these sides. This is going to be the opposite side. This is going to be the hypotenuse. And this is going to be the adjacent side, just to remind you of what's what. Now to label the sides and turn them back into x, you need to look back up at the trig function you used earlier in the problem. So the only trig function you had to work with was this one right here. X is equal to 4 times the secant of theta. So we'll bring that one back down and rewrite it again. So you know that x is equal to 4 times the secant of theta. And what that means, divide, and you'll have x divided by 4 is equal to the secant of theta. But just a reminder, what the secant is, that would be the hypotenuse divided by the adjacent. That's just the definition of the secant. So now you know how to label the sides of your triangle. You know that the hypotenuse is equal to x, so here's the hypotenuse, and it's x, so go ahead and put an x right there. You know that the adjacent is 4, so the denominator is the adjacent side, it's 4, so go ahead and put a 4 right here. And then just like we've done in the earlier problems, the remaining side is always equal to whatever that original square root was. So in this problem, the original square root was the square root of x squared minus 16. So come down here, and this side's going to be the square root of x squared minus 16. Now, if you were to use the Pythagorean theorem, you'll see that it all works out just fine. Okay, now that you've got the sides of the triangle done, you're ready to change this answer in terms of theta into a final answer in terms of x. So here's the constant 2. And to change that final thing on each one of these, you just have to look at your triangle and get it. So first of all, you want to change the tangent of theta. So in this problem, the tangent of theta, now the definition of the tangent is the opposite over the adjacent. So the opposite over the adjacent. So look at your triangle and just write those down. In your triangle, the opposite side is the square root of x squared minus 16. So this is going to be the square root of x squared minus 16. And the adjacent side is 4. So this is going to be a 4. So the tangent of theta turns into this right here. So that's what the tangent of theta is equal to. So you can replace this tangent of theta with what it's equal to. So this will turn into the square root of x squared minus 16 divided by 4. Then you've got minus, now you've got theta. Now, a couple ways you can find theta. Use the easiest one. And in this case, you can use any one of the trig functions to find it. But since you've already kind of got it set up here, let's go ahead and use this. You know that the secant of theta is equal to x over 4. Therefore, theta would have to be the inverse secant of x over 4. And now you've got what theta is equal to. So in place of theta, you can put the inverse secant of x over 4. And then don't forget to tack on the plus c, and you are finished. So again, here was the answer in terms of theta. You turn it into a final answer in terms of x. And again, if you just follow the steps, they'll pretty much guide you straight through. So looking back up at the beginning of the problem again, change it from an x problem using these two formulas right here. change it from an x problem into a problem in terms of theta. Go ahead and find the antiderivative, and you'll get an answer in terms of theta. Now, to change it from theta back into x again, you have to draw the triangle and label the sides. Once you've got the sides labeled, you can use the sides of this triangle to change each one of these things back into this. So you change the tangent into this, and you change the theta into this, and you got the final answer. So there's another example with trig substitution.